Hello, AP Statistics. This is section 9.1, significant tests, and we're just going to talk about some basics. Okay, this is pretty simple, easy stuff. First thing, we're going to just talk about some definitions. Okay, and we're going to use these definitions from now until the end of our quarter. Okay, the first one's called a null hypothesis. Okay, it is defined as a claim we weigh evidence against in a statistical test. Okay, and we compare that to an alternative hypothesis, which is the claim about the population that we are trying to find evidence for. Okay, we will always use two symbols to help represent the null and the alternative hypothesis, and they will appear like this. This, of course, is the null, the item that you see first. Okay, so it looks like an H sub 0 with a little colon behind it. Sometimes I call that the ho. Okay, and below it will be the ha, which is the alternative hypothesis. Okay, so we have these really nice abbreviations to help represent this long terminology. Okay, and we'll be using those throughout this small lesson. Okay, so here's how they're used. Okay, we're going to look at what the null hypothesis, and this is the original claim. Okay, it's the claim that's stated to be true. Okay, and this particular problem, it says Trident chewing gum claims that 4 out of 5 dentists prefer their gum over other leading gums. Okay, and so what I'm going to do is I'm going to put some symbols, okay, behind the null hypothesis, which is this H sub 0. Because I'm talking about proportions here, okay, and proportions being 4 out of 5 dentists, okay, or 80%, I'm going to represent that type of mathematics behind my null, okay, and I'm going to symbolize that using a P, like we did in our previous chapter. Okay, so for my null, okay, I'm going to put P is equal to, okay, and whatever the original claim is, okay, and in this case, it's 4 out of 5 dentists, okay, 4 out of 5 we know is the same as, again, 0.80, okay. You'll notice that as we work through all these problems, that this top item here, okay, with a null hypothesis, we will always have an equal to sign there. Okay, so for our particular class, always expect to have an equal to in that position. Okay, if you have any other symbol there, any other inequality, something's not quite right. Okay, we also use a population P symbolized with behind our null hypothesis. Okay, so notice that it is just a plain P. There are no P hats when making a null or alternative hypothesis. Okay, so don't ever use the P hat. We're only going to be talking about P's. Okay. Now the alternative is that it may be something different than 4 out of 5. How do we know that 4 out of 5 dentists across the world prefer Trident over any other gum? Okay, so maybe I think it's something different than 4 out of 5 or 80%. And that's what my alternative is. Okay, it's the other claim that we believe that may be more truthful. Okay, and so we believe that it may be something other than 80%. And what does that mean? Well, I'm going to write P also. Okay, and in addition to this, instead of putting an equal to sign like I insist that we have above, we're going to have an inequality here. Now, what is an inequality? It could be a not equal to sign like you see here. It can be a less than sign, or it can be a greater than sign. Okay, we don't typically put little equal to signs underneath the less than or the greater than sign. We kind of leave these as you see them. Okay, so one of those three, and in this case, because it was very neutral, we just said it was a not equal to sign. Okay, that maybe it was something other than 4 out of 5 dentists preferred Trident gum. Maybe it was a little bit more, maybe a little bit less. We're not really quite sure. Okay, finally, we did this last piece with confidence rules in our previous chapter. Okay, and what this means is that we need to define P. Okay, and so we're going to script this out. P is the true population proportion of dentists who prefer Trident gum over other leading gums. Right? I want to emphasize that the word underneath here is population. Okay, this is a description for a parameter, and that's how I'm going to define it as P. Again, we do not have P hats here. And again, we're going to talk about proportions in this particular problem. Okay, so the true population proportion of dentists who prefer chewing gum over other leading gums, we must make sure that we define that variable P as we wrote it symbolically within our null and alternative. Okay, some other things to keep in mind is that these numbers in the back will always be the same. Okay, so while your symbols here will be different, okay, these numbers in the back of this are the same. These symbols here will also be the same. Okay, so if you put a population proportion P represented here, you'll also see it underneath. Okay, so again, no P hats. We're not dealing with samples when we are looking at this type of work. Okay, we're describing population parameters. Okay, the other type that you will see, okay, goes into our next question. Doesn't deal with proportions, but it deals with averages. Okay, so I just made up this problem that says 17 magazine states that the average price for a high school prom dress is $78.74. Just made that up. Many of the girls who read this article believe the average to be higher. Okay, so like before, the null, which is h sub 0, is the original claim. Okay, and is the claim that 17 magazine is stating, and it relates to this number that you see right there. And we're talking about averages in this case. Okay, we're not talking about proportions. So I'm going to use a symbol mu within my null and in my alternative. So for my null, the original statement was mu is equal to 78.74. Again, notice that I have an equal to sign there. That should be true, okay, for all of our null hypotheses in this class. Again, I'm using a population parameter mu, okay. I am not using the symbol X bar in any case here, okay. So no X bars. I'm going to kind of scratch that out, okay. It's hard to draw an X like you're going to X out over an X, if that makes sense. That's why I just scratch that out. Okay, so yeah, don't put an X bar in this position. Always have a mu when we're dealing with averages. Okay. However, in this case, it says many of the girls who read the article believe the average to be higher. Okay, so that means I'm going to have an inequality for the alternative that supports this description. All right, so when I write my alternative, okay, again, remember these must match. I'm not using P's like I did before. I'm using mu's because I'm dealing with averages. Okay. And again, this symbol here needs to be an inequality. Okay. It does not have an equal to sign underneath it. Okay. It's just mu is greater than 78.74. And again, we wrote a greater than sign because it was supposed to be higher. Finally, the last thing that we're going to do is we're going to define mu. Okay. In mu, as it was prompted in this question, is the true population average price for a high school prom dress. Okay. If you want to use the word mean instead, that is certainly great. But again, with our symbols, we are not going to use X bar. Okay. These are no-nos. Okay. Everything is mu. Again, notice these numbers are the same as they always will be. And the equal to is on this top part, the inequality is on the bottom. Okay. And again, these population parameters of mu are also the same. All right, so here's what I want you to do. I've got 4 that are kind of like this. You're going to have to determine whether you're going to use a P for your null and your alternative hypothesis. Okay. Making sure that it always has an equal to sign there. Or is it going to be a mu? All right, and again, one way you can tell if it's a mu is if it just says average. Okay, and if it says average there, you know you're good. Oftentimes the word proportion or some hint of a fraction is listed for a population parameter P. Okay, so here's what we'll do. If you move on to the next question, okay, as followed by the notes, here's the first one. I want you to pause this video just for a second and see if you can fill in the respective items. Okay, see if you can fill in the null, the alternative, and then the definition. Okay, you're going to put some symbols here, either a p or a mu, and you have to decide p or mu, what am I going to set that equal to, and how am I going to describe that? Okay, so hit pause, try it on your own, and see if you can figure out this answer. All right, it is said and believed that the average amount of money that Americans spend on food, fast food annually is $1,225 with a standard deviation of 122. So again, dealing with averages means I'm going to work with mu. One person believes that the average is higher. Okay, so that tells me about the inequality that I will use for my ha. Okay, and so if I write my null, I know I'm going to use the mu. It's equal to 1,225. Again, always an equal to sign on the top, at least for this class. Okay. The alternative, since it says that they believe the average to be higher, is going to be a greater than sign. Okay. And then, of course, we will again identify that each of these are the same. They're both mu, and these are both 1,225. And then we'll describe mu, and it's usually stated somewhere in your work. You could kind of just follow it along as the problem reads. And I did very much the same thing. Mu is the true population average amount of money spent on food last year, and more specifically, it is fast food. Okay. Notice again that I wrote population average. Okay, that is sometimes very important on AP tests to include not just the average, but the word population there, so it's not confused with sample. Okay. Again, X bars, no, don't put those in your work anywhere. Okay. All right, let's look at the next one. If you don't mind, hit pause for a second. Okay. See if you can write your null and alternative hypothesis on your own in a description of your population parameter, whether it is a mu or a p. Okay. So hit pause and we'll go over our answer in just a second. All right. If you look at your null hypothesis, let's read this. It says that the proportion, well, right there, that kind of gives me a big hint. Free throws made amongst college athletes in women's basketball games is about 75%. Newspaper columnist believes that it to be different than 75%. Okay, so not necessarily more than or less than. Okay, so we will identify that inequality in our alternative. And we'll start with proportions. And since the word proportion is here, we will use P. Remember, P hats are a huge no-no. We don't do those. So our P is equal to 0.075. Okay, that is the original claim. The alternative is that it has to be something different. And if it's something different, that means it is a not equal to. Okay, so it wasn't better, it wasn't worse, it was just something different than what we originally thought or what was originally claimed. And so we put a not equal to sign there. Okay. Finally, we have to define P. And again, P is described in a sentence somewhere up here. But P is the true population proportion of free throws made amongst athletes in women's college basketball games. All right, so you have to write that long sentence to help define P. Again, no hats, no P hats in this exercise. Okay. All right, there's two left. It says teenagers love movies. One high school newspaper provides a claim that 45% of all movies have seen a movie within the last month. Individuals believe this proportion to be less than the claim. Okay. Therefore, they asked 200 random teenagers if they've seen a movie within the last month and record the number of successes. All right. So again, you're going to have to decide if this is a P or a mu that we're using. Okay. Hit a pause and record your answer, and we'll see if we got the same stuff. All right, because it does give you a percentage here, which is 45% of a success. Okay, 45% of teens have seen a movie in the last month. That's the claim. That's what I'll write up here. Again, another equal to sign, a plain P with no hats. Okay, so again, no P hats. Okay. Okay, no p hats. Is equal to 0.45. They think that is less. Okay, so for my alternative, I'll address it that way. Okay. And then finally, okay, I'm going to write what P is. P is equal to the true population proportion of teenagers who have seen the movie within the last month. Okay, and again, I'm going to write population there. I'm going to write proportion there. I don't ever want to say just number, the true number of teens. I'm not talking about numbers here. We're talking about proportions. Okay, so be careful not to write the word number. That's another kind of just kind of a taboo word that isn't specific enough when we address this definition. Okay. Again, notice these are the same numbers here, 0.45s. These are also the same too, population parameter P's. Okay, always an equal to sign on top, inequality on the bottom. All right, one more. Give it a try. We'll read it first. It says Perry High School students are super scholarly, holding an average GPA of 3.69 and a standard deviation of 0.44. One jealous Basha High School student believed the GPA average to be too high. Okay. The Basha High student randomly selected 60 Perry High School students and asked for their GPAs. Assume the distribution to be normal. Okay. So one last time, see if you can figure out whether we're dealing with proportions or averages. Okay. And write them to good, null, and alternative hypothesis, and describe either P or mu using words. Okay, hit pause. This is the last one. Takes just a couple seconds and we'll be done. All right, so because this says averages, we're going to use this guy. All right, again, no X bars. Okay, bad. Okay. Mu is equal to 3.69. Again, always an equal to sign there, always a mu or a p, but in this case it's mu because we're talking about averages. Okay, 3.69. And if they think it's too high, that means they believe the average to be less than. Okay, so that doesn't mean to be a little bit of a trick there. Okay, less than. So yeah, if it's too high, then you must believe that it's actually smaller than that. So mu is equal to 3.69. Okay, and again, we will define mu, because it is an average, as the true population average GPA for Perry High School students. Okay, again, we need to include the word average here. Using the word mean is certainly okay. And population, okay, is also strongly encouraged to be put there. Okay, we want to make sure that we identify that this is a population supporting this mu parameter symbol. Okay, so all right, so that is it. Okay, I have a small assignment that I want you to practice. Okay, it's page 551. For 1 through 4, you're actually going to have to write out a null, an alternative, and when they say define the variables, you're going to have to tell me what either p is equal to or what mu is equal to, like we did in this exercise. Okay, 7 through 10 are a little bit easier. They actually write the symbols out for you. They're going to write out a null and they're going to write out an alternative, and they're going to do something unique about it. Okay, they're going to do something like this, and they'll say, hey, what's wrong with this? And you'll have to look at this and say, oh, there's something not right there. These are written backwards. It should be the equal to signs on the top, the inequality should be on the bottom. Okay, or maybe they'll do something like this, where instead of putting p's there, they'll put p hats. Okay, and you have to say, hey, you know what, p hats are not appropriate because those deal with samples. Okay, and what we want are population proportions. Okay, or maybe they'll put an X bar here. Okay, or maybe they'll put, for example, with a null, an alternative, maybe they'll say, hey, this is 3 and this is 2. And again, these have to match. So there are going to be mistakes in the problems for 7 through 12, and you got to figure out what those are. All right. I'm sorry, I can't be there today, but I hope you have some success with this. I don't think it's too bad. And once we're done with this, we will move on to section 9.2. All right. Hope you have a great day. We'll talk to you soon.